these types of questions can be really time consuming. So we have two situations. We have the entire class and then entire class minus the 5 students who took this test. So here I'm going to call this number x, and this would be x plus 5. The average for the entire class is n, not to confuse with the numbers. And this is for the class without the 5 students. Question is n greater than m? So the question is really about the average. So I'll start with statement 1 says mode of the entire class was greater. So mode is the most frequently occurring value. And so if that's the case, then clearly the new mode comes from these 5 students. And it could come up in different ways. But let me just put an example that if, let's say, all of them were 100, all 5 students, and that's, in this case, let's say the mode is 100 indeed. I just have to find the most frequently occurring, let's say, is 15 here, and there are only 3 of those. So I'll satisfy this condition. Now, in this case, if the average of these students without those 5 students, let's say the average was 50 here. Once I add these 5 students with the average of 100, the average of the entire class will go up, will be indeed more than 50. So this would be an example of a yes. But these values could also be, let's say, 5, 5, 5, and 5, and 5. And the mode here for the original, let's say the mode was 2. And let's say it occurred 3 times. It could be 4. I'm just giving you a particular example. So I do satisfy the statement. The mode of my entire class is indeed greater. And of course, this also assumes that there aren't any other values that occur more than 5. Now, in this case, again, let's assume the original average is 50 here. When I add 5 more students with values of 5 each, which is significantly lower than the existing average, it will bring down the average. So the entire class average now will be less than the original. So that would answer this question as a no. So 1 alone is insufficient. So this does take time. I mean, I can see some students kind of just doing it mentally, but I gave the details to kind of so that you can see it with clarity. The next statement is that the range for the entire class was the same. So the range remained the same, and that's just the difference between the least and the greatest. Whatever that is, the least could be, let's say, 1. Greatest could be, I don't know, 100. In this case, the range is 99. The key thing is that these additional 5 students, their scores have to fall between the least and the greatest, because the range doesn't change, or it could equal these. So then I have to come up with the same examples, similar examples, to then argue that the mean can go either way. Again, let's assume the original mean was 50. And if all 5 of these students scored 2, then the average would go down. But if they all scored, let's say, 99, then the average would go up. So that would be our yes and no. Now, when we combine 1 and 2, we'll see that we can still, I mean, again, I'm going to use those same examples that I used earlier. So instead of the hundreds, just think of 99s. And then instead of the 5, thinks of all 5 being 2. And here, for the original one, I can just say the original mode was 1, so that I still satisfy statement 1. So even when I combine them, I'll still end up with a yes and a no, because I can get a lower average or higher average for the combined set. So 1 and 2 together are not sufficient. So, I mean, in the exam, to do these types of questions, I kind of anticipate when I see them. I know that I have to be very careful, and just to be for me to have 100% accuracy, I do have to kind of go through these examples so that I leave no room for any doubt. So that's kind of how I would think about this question. So the answer is E.